Hello and welcome to my YouTube channel Online Math for You. Today our topic is rational numbers. Now let's get started with the topic of today's discussion. Now before knowing rational numbers, we should know one or two more terms about rational numbers. First of all, we should know integers. Now, definition of integers is an integer is a number that can be written without a fractional component, such as 2, 3, minus 2, minus 1, 0, etc. or integers. But 9.75, 2.3, root 2, root 3 are not integers. Second one is additive inverse. If we want to know additive inverse of a number, then simply we change the sign of that number. Such as if we want to get additive inverse of 3. Additive inverse of 3 is minus 3. Additive inverse of minus 5 is 5. Simply. Now, we will know the definition of rational numbers. Rational numbers definition: the numbers which can be expressed in the form of P upon Q, where P and Q are integers and Q is non-zero, not equal to 0. P can be 0, but Q cannot be 0. Now, if we want to express a rational number on a number line, then let us see how can we express a rational number. If I have 3 upon 5, here we see that denominator is more than numerator, or numerator is less than denominator. Now, before expressing it on a number line, we should know something about it. Let us see one or two more rules. Case first. If numerator is less than denominator. Case first, numerator is less than denominator. Then in this case there are two more cases. If this type of number is positive or negative. If this number is positive, then this number lies between 0 and 1. And if this number is negative, then it lies between 0 and minus 1. Now we take 3 upon 5 and see that what happens. 0, 1, 2, minus 1, minus 2. Now 3 upon 5. Numerator is less than denominator and it is positive. Then it lies between 0 and 1. Now we see denominator, that is 5. We divide the number line between 0 and 1 into 5 equal parts. 1, 2, 3, 4 and 5. And we take third one. 1, 2, 3. This. It represents 3 upon 5. Understood? Now, if this number is negative, let us see another number. 2 upon 3 minus. Now we divide the number line between between 0 and minus 1 into 3 equal parts. 1, 2 and 3, and we take second one. 1, 2. It represents minus 2 upon 3. Now, case second, numerator is more than denominator. Now, in this case, we also have two more cases. Positive and negative. Then see some examples. 5 upon 3. Here numerator is more than denominator. Now we divide numerator by denominator and see that it can be expressed as 1 whole 2 upon 3. 1 whole 2 upon 3. Now see that this number line. Now 0, 1, 2. Now, in this case, we see only this one, whole number. It is 1. Then 1, and after 1 is 2. Then this number lies between 1 and 2. 1 and 2. Now we divide the number line between 1 and 2 into 3 equal parts. 1, 2 and 3, and take second one. 1, 2. Then it represents 5 upon 3. Now, similarly, we can draw negative rational numbers in the number line. So, next is, if we want to find some rational numbers between two rational numbers, such as 2 upon 3 and 1 upon 6. Between these rational numbers, we want to find 10 rational numbers. 10. Find 10 rational numbers between 2 upon 3 and 1 upon 6. Now, we should take LCM of 3 and 6. Now, LCM of 3 and 6 is 6. Now, 2 upon 3 can be expressed as 2 upon 3 multiply 6 by 6. We multiply this number numerator and denominator by 6. Then 2 ja 3 2 ja 6, then 2 upon 6 4 upon 6. Now next one is 1 by 6. We write it as it is because its denominator is equal to LCM. Now these are like terms, like rational numbers. We converted these two rational numbers into like rational numbers. Like rational numbers, by like rational numbers we mean equal denominator. Now we see that we have to find 10 rational numbers between this and this. Now forget 6 for some time. Now see, 1 and 4. Between 1 and 4, how many numbers are there? There are 1, between 1 and 4, 2 and 3. 2 numbers. Now if we multiply these two rational numbers by some number, suppose we multiply it by 2. 2 ones are 2, and this one 2 4s are 8. between 2 and 8 there are numbers less than 10. Now multiply it by 3. If we multiply it by 3, then 3 and 3 for the 12. Between 3 and 12 there are not sufficient rational numbers. Now multiply it by 4. If we multiply it by 4, then we get 4 and 16. Now we can get 10 rational numbers between 4 and 16. Now multiply it by 4. Then multiply 4, 16 upon 24, 4 upon 24. Now write 10 rational numbers between 4 upon 24 and 16 upon 24. Now 10 rational numbers between 2 upon 3 and 1 upon 6 are 4. And after 4, 5 upon 24, 6 upon 24, 7 upon 24, 8 upon 24, 9 upon 24, 10 upon 24, 11 upon 24. Now count 1, 2, 3, 4, 5, 6, 7. 12 upon 24, 13 upon 24, 13 upon 24, 14 upon 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now these are required rational numbers between 2 upon 3 and 1 upon 6. That's it.